Hello all, welcome to Code Hub. Today let us solve the LeetCode's daily challenge, and the problem is kth smallest element in a sorted matrix given a n cross n matrix where each of the rows and columns is sorted in ascending order. Return the kth smallest element in the matrix. So note that it is the kth smallest element in the sorted array, not the kth distinct element. So we have to do this problem. So obviously the brute force approach that comes to our mind is we have a matrix, so we will be storing it the whole matrix into a vector or an array, and after which we will be sorting that whole entire vector and return the k minus 1 k-1th element since it is zero based indexing. And what will be the time complexity here? We will be sorting this whole vector, so it is order of m log m, where I will say that m is nothing, m is equal to n square, since there will be n square elements, and the space complexity will be we will be using a vector, so m is nothing but the n square elements, m equals to n square elements. So we can this is the obvious approach that comes to our mind. Let us think of some other approach so that so somewhat little bit we can improve our the time complexity. Here obviously whenever we face a problem to find a kth smallest or kth largest, we can use a priority queue where we will put all the elements in the priority queue in an increasing order fashion. That's sorry, in an decreasing order fashion, so that we will be using a max heap. Why it is max heap? Let us dry run this problem so that it will be clear why it is a max heap. So we can traverse this whole matrix. First we will have a max heap, so we will be having an increasing order in from right to left. Let us put that let us do a dry run here. First we'll be inserting one into a max heap, since it is not having k elements. Then we will put 5 in our max heap, since it is not having k elements. We will put even 9, then 10, then 11, then 13, then 12, then 13. But now if you see here, there are 8 elements already. So whenever we have 8 elements in our, whenever we have k elements in our priority queue, after which if we want to insert an e element, then we have to do some then we have to take a some of the logic. What is that is, if there is a k element, then if the incoming element is greater than the top element, then we don't want to insert that top element. Since 15 is greater than top element, then we don't want to insert this 15. After which we have exhausted the elements from our matrix. So the top element will be the kth smallest element in from this ordered matrix. So let us consider we are having 6 here. Let us consider we are having a 6 here. We have inserted k elements, and next we want to insert 6. Before inserting 6, we have to check for the condition whether the top element is greater or smaller. Since 6 is smaller than 13, this 13 is useless. This 13 is not needed. So what we have to do is we have to remove this 13. So once we remove this 13, we have to insert this 6. Where it will get inserted, here it will get inserted here 6. So now we have 13 elements, and this 13 is the 8th smallest element in our entire matrix. So this is how we will be doing. So what will be the time complexity here? The time complexity will be order of k log k. Since we will be having k elements inserted, and I say k elements inserted. Since there are k elements inserted, there will be time complexity is order of k log k, and the space complexity will be order of k. Will be reducing the space complexity. But if there is if the k is equal to n, then obviously the space complexity will be order of n, which is n is equal to the n square elements. So let us do this approach here. First we will be initializing the priority queue in PQ, and next we will be traversing the entire elements from the matrix int n equal to matrix dot size. It is an n square matrix, so n we can have n itself. I equal to 0, I less than n, I plus plus, or in j 0 till n j plus plus. If my pq dot size is less than k, then we can just push the elements into our priority queue matrix of I j. If this is equal to or greater than the, it will not be greater than, but if it is equal, if the priority queue size is equal to the size k, then what we have to check is if the pq dot top, if the top element is greater than the matrix of ij. If the top element is greater than matrix of ij, what we have to do is we have to remove the top element, then we have to push pq dot push of matrix of ij. We have to push that current matrix element, else we don't want to perform any operation. So finally we will be just returning the pq dot top. So let us run our code. It got accepted. Let us use the example test cases and run. Okay, let us submit our code. Yeah, it got accepted, and this is the priority queue solution. Than this we can optimize this, but that approach is based on binary search. So I'm not going to take this approach. Hope I made clear with this priority queue solution. Let us see in tomorrow's LeetCode daily challenge. Until then, bye.